Hi friends, good evening. Today we are going to start with a new chapter, that is differential equation, right? Alright. So differential equation, alright. So see, what is a differential equation? You already know. Suppose a simple harmonic motion you consider. What is a displacement equation you studied? Y is equal to a sin omega t, right? Then what is we need a differential equation corresponding to it. So differentiate first time, then dy by dt is equal to a into sin omega t on doing cos omega t into omega. Again differentiating, then d square y by dt square equal to, see, again differentiating means a omega into cos omega t on differentiation minus sin omega t into omega t again doing omega. Then what is d square y by dt square? That is equal to minus omega square and a sin omega t. A sin omega t is again y, then minus omega square y, then d square y by dt square plus omega square y equal to 0. So this is the differential equation corresponding to oscillation of a symbol, variation of amplitude, that like a simple harmonic motion, right? Corresponding differential equation. When this differential equation you solve means the solution you get as y is equal to a sin omega t. This chapter we mainly focus some differential equation given, how to find the solution of such a differential equation. Alright? Alright. Now degree. What is degree and order? Right? So degree of a differential equation is the degree of the highest derivative occurring in it when the differential coefficients are made free from radicals and fractions. That means every differential equation, for example, d square y by dx square plus 3 dy by dx, say plus 3y equal to 0. This is a differential equation. What is the highest differential order? That is order, that is 2. Now highest differential exponent, that means this is the differential, highest differential you consider, that is second derivative, right? What is its exponent? Its exponent is 1, right? So that is the degree. Then degree is equal to 1, right? So order of the differential equation is the order of highest derivative occurred. So here second derivative is the highest order, right? So order is 2 and a degree is the exponent of the order considered, that order considering derivative. Exponent of such a order considering differential is what? That is degree. Alright? Alright. Now see, here I given some differential equation. So let us find out the order and degree. See, first equation here, what order 2, right? And what is degree? Degree is, that is exponent of order taking term, that is 1. But here what is the degree and order? It's actually, it is free from fraction and radicals, right? So first we have to remove this root. For example, if you expand this xy minus x dy by dx, now take a square, am I right? Take a square, then this root we can remove, that is 1 plus dy by dx the whole square, right? Now what is the highest derivative? 1 only, right? Then maximum highest exponent of that term 2. Then order 1, degree 2, right? Degree 2, am I right? Now here also, see, here d square y by dx square, its exponent is 2, but the highest derivative is third degree. Its exponent is actually what is degree, right? So here order 3, but degree 1 only, right? What is degree definition? It is the exponent of the order taking derivative. Understood? Now here there is a 3 by 2 here, that is a fraction, we should remove. how we remove square both side. Then what you get? 1 plus dy by dx whole square whole cube, right, equal to 5 d square y by dx square whole square. Now what is the highest differential is 2, right? Then order 2 and degree exponent of this highest order taking term 2, right? Alright. Here highest derivative is d square y by dx square. Alright. Now another term is d square y by dx square whole cube plus 3 dy by dx. Highest differential is 2. But there is a condition, if sine or cos trigonometric function came in the equation as an angle is as a variable, that is a y. It is a differential equation of y only, right? Variable is y. Then that variable y or dy by dx come as sine or cosine any trigonometric angles, then degree not defined. So here degree order we can say 2. Okay, but because of this dy by dx came as the angle, then degree not defined. Okay. Alright. Now let us go to another section. Formation of a differential equation. Right? A differential equation, see, from a differential equation from a given with n constant, differentiate n times. So this is the condition. Suppose to form a differential equation from a given data, if that data consists of two constant, means you have to differentiate 2 times, then only you can eliminate that constants. For example, let us see how form differential equation. Find the differential equation. Find the differential equation whole straight line in the xy plane. See how we represent a straight line in the xy plane, right? Any straight line we can represent like this, right? So this is what intercept, right? And its slope is tan theta, right? Tan theta is equal to m. What is the general expression? Y is equal to mx plus c. Now what is the condition? Here we have two constant m and c. So we have to differentiate 2 times. What is that? Then dy by dx is equal to, right, m into 1, right, plus 0, right. Then d square y by dx square is equal to what? 0. So this is the differential equation. Am I right? Alright. So d square y by dx square is equal to 0. This is the equation of a differential equation corresponding equation of a straight line in xy plane. Alright? Alright. Now next question is, find the differential equation all the straight line passing through origin. If it is passing through origin means, right, like this only, right. Origin means y is equal to mx, no intercept. Then you have to differentiate 1 time only. Dy by dx is equal to m, right. One constant means 1 time you differentiate. Now this dy by dx you substitute here. Y is equal to, what is m value? Dy by dx. So dy by dx into x. Then y minus x dy by dx is equal to 0. This is the differential equation corresponding to it. Alright? Alright. Now find the differential equation of all circles passing through the origin and center lies on the x-axis. Alright. So find the differential equation of all circles passing through the origin. So you have one circle that is passing through the origin and center should be on the x-axis. So passing through the origin and the center is now on the x-axis. What is the equation circle correspond? What is the equation of a circle corresponding this? this is a, suppose radius is a, then this is a0, right? Then what we studied, touching x-axis only, then x minus a, the whole square, and y-axis, center is on the x-axis, then y minus 0 the whole square equal to a square, right? This is the general equation of the circle passing through a, center is a0 and radius a, right? But it touches the origin, alright? Now, that is x minus, now we have only one constant, x minus a whole square plus y square is equal to a square. One constant means we have to differentiate only one time. That means 2 into x minus a, right, plus 2y dy by dx, right, equal to 0. Now you have to solve this 2 to go to this side and 0. Then a is equal to what x plus y dy by dx. Now what you have to do, this a value you substitute here, right? That means x minus, what is a value? X plus y dy by dx. Y dy by dx, right? Then a value I substituted here, whole square plus y square equal to a square, right? A value again you have to substitute here. What is that? Is x plus y dy by dx the whole square, right? Now substitute this x cancel, this minus, then y square dy by dx the whole square plus y square equal to, here expanding, x square plus y square dy by dx the whole square plus then 2xy dy by dx the whole square, right? Then this term cancel, right? Then what is the general equation? 2xy dy by dx the whole square plus x square minus y square is equal to 0. This is the differential equation corresponding for the circle passing through the origin and center lies on the x-axis. Alright? Alright. Now this is all about this section, and next class we discuss about solution of a differential equation, how to find a different solution in different cases. Alright? Alright. Thank you.